In this video, we're going to continue our discussion of integration, and we're going to do some indefinite integration. However, we're going to learn how to reverse the chain rule, and one of the strategies that we'll use to reverse the chain rule is the substitution method. So if you were in my class, I would encourage you to stop the video, do the warm-up, and then resume the video, because the warm-up is going to lead us into our discussion about integration, or reversing the chain rule. So in problem number 1, we're going to find the derivative. We have an inside function of x squared plus 1. So our inside function here, and we have our outside function of the cube. So when we find the derivative, we take the derivative of the outside. So we have 3 of the quantity, x squared plus 1 to the second power, there's my power rule, over 3, times the derivative of the inside. The derivative of x squared is 2x. And then we have the derivative of 5, the derivative of a constant is 0. So if we clean that up and reduce, the 3's divide out, and we get 2x times x squared plus 1 quantity squared. So that is the derivative. In number 2, when we find the derivative, our outside function is sine, and our inside function is 5x plus 3, so we take the derivative of the outside. The derivative of sine is cosine of the angle, and then by the chain rule we multiply by the derivative of the inside, or the derivative of the angle, which in this case is 5. So that's how you find the derivative using the chain rule. Now we're going to reverse the chain rule, and now that we have a derivative, we're going to go back and we're going to find the original function. So notice that in problems 1 and 2, I'm going to find the antiderivative of the two problems that I just found. So I'm going to find the antiderivative of 2x squared plus 1 quantity squared, and find the antiderivative of 5 cosine of 5x plus 3. When we reverse the chain rule, there are some important things that you have to be in place. First of all, there has to be an inside function, just like when you're doing the derivative of a chain rule. And the inside function here is x squared plus 1. So there's our inside function. And then to reverse the process, you have to make sure that the derivative of the inside function is in the expression. So if the inside function is x squared plus 1, 2x has to be a part of that expression. So the first part of reversing the chain rule is to identify the inside function. And the second part of the chain rule is to check to see if the derivative of the inside function is part of the integrand. Now remember, the integrand is the expression that we are finding the antiderivative of. Left out an n there. Right, so this whole thing is the integrand, is what we are integrating. So we identified our inside function to be x squared plus 1. We took the derivative of the inside function to be 2x, and it is part of the integrand. And so if that's the case, if both of these are true, then simply integrate. Now we're going to do this one without using, these two without using substitution, and then I'm going to show you how to do it with u substitution. Most people actually prefer using u substitution all the time. But in this case, since I see that the derivative of the inside function is present, now we already know what the answer is going to be. This is what we have to get back to. When we find the antiderivative, we find the antiderivative of the inside-outside function. So once we know that the derivative of the inside function is there, we're basically kind of ignoring it. So when we reverse the chain rule on x squared plus 1 quantity squared, we increase the power by 1, so we have x squared plus 1 quantity cubed divided by 3 plus c. Now, in the original problem we had a plus 5, but we have no way of knowing in this problem what that constant was. So plus c holds the place of the 5 or whatever other constant might be going on there. All right, let's take a look at the second one. And let's follow our little handy-dandy steps here. The first thing we're supposed to do is identify the inside function. So the inside function in this problem is 5x, it's the angle. Then, second thing, check to see if the derivative of the inside function is part of the integram. Well, the derivative of 5x is 5, and we see that it is part of the integrand. Once it's there, we basically ignore the derivative of the inside, since we know it's there. We reverse the chain rule, so we're going to find the antiderivative of cosine, which is sine of the angle plus c, which takes us back to our original function. Now this process works. Oh, we didn't finish. This process works whenever the derivative of the inside function is part of the integrand. Now, if the derivative of the inside function is not part of the integrand, then we have to manipulate the expression, and we'll talk about that actually in a different video. We're going to focus here mostly on the ones that don't need manipulation, maybe a little bit. All right, let's take a look at identifying inside and outside functions. This should be pretty easy because this is something you had to do with the chain rule. So in this case, the inside function is 2x minus 1, and then the derivative of the inside function is 2. So we have our inside function, and we have the derivative of the inside function. So if we were going to find the antiderivative, all we would have to consider is 2x minus 1 to the 1/2 power, and we would reverse the power rule, increase the power by 1 and divide by the new power. In the second problem, the inside function is theta cubed. The derivative of theta cubed is 3 theta squared. So once we find out that the derivative of the inside function is there, we're basically reversing or finding the antiderivative of sine of theta cubed. So again, once we know that the derivative of the inside function is there, we basically ignore it. In the third one, the inside function is 1 minus 2x squared. The derivative is negative 4x. So we have our inside and we have the derivative of the inside. So now we would find the antiderivative of 1 minus 2x squared to the negative 2 power. And actually, I'll go back and do those. Now, in number 4, you have to be careful. Remember, this is the same thing as the cosine of x, quantity squared times sine x dx. So the inside function is cosine of x, and the derivative of that, the derivative of cosine, is negative sine x. Now, we have sine x, but we don't have a negative, so we would have to figure out what we're going to do to get that negative in there. And then once we do, we're again basically finding the antiderivative of cosine of x squared. And we know that the outcome would be the opposite of that to take care of that negative. So in this case, reversing the power rule, we would increase the power by 1. So we'd have 2x minus 1 to the 3/2 power multiplied by 2/3 plus c. I'm finding the antiderivative. The antiderivative of sine is cosine plus c. Check that out. The derivative of cosine is negative sine. Oh, so we got caught right there. So we need to add the negative in there because the derivative of cosine is negative sine. So the antiderivative of sine is negative cosine. On the third one, we're going to increase the power by 1, so we get 1 minus 2x to the negative 1 divided by negative 1. And then in the third one, the derivative of cosine is negative sine, so we're going to need our negative again. We're going to increase the power by 1, divide by the new power, and then our plus, our constant of integration. Okay, so that's reversing the chain rule without using substitution. All right, so now I'm going to walk you, the last thing I'm going to do in this video is walk you through how to do the process using U substitution, which I find many students prefer to what I was just showing you. So if the derivative of the inside function is not part of the integrand, you can use U substitution. Now in this case, you'll notice that the inside function, so that's the first thing we're going to do, is we're going to let U equal to the inside function. So we're going to take out a complex variable expression and substitute a simple variable expression. So in this case, the inside function is x squared plus 1. So U is going to equal to x squared plus 1. The second thing we're going to do, just like in our other steps, is we're going to take the derivative of both sides. What I mean by that is we're going to take the derivative of U in terms of U, so we get du, and we're going to take the derivative of x squared plus 1, which gives us 2x dx, because we're taking the derivative with respect to x. Now notice in the problem I have an x squared plus 1, so everything is good there, and I have an x, but I don't have the complete derivative. I don't have a 2. So that's where we're going to have to do a little bit of manipulation. We have to replace, we're going to replace everything up here. So we're going to replace the x squared plus 1 with u. We're going to replace the x, but I don't quite yet have a replacement for x. So to find a replacement for x, I'm going to get, also I need a replacement for dx. So let me clean that up a little bit for you. So I need a replacement for x squared plus 1, and I need a replacement for the x and the dx. So notice in step number 2, I have an x dx sitting right here, and to get that by itself, I'm going to divide both sides by 2. So du over 2 is equal to x dx. So now I can rewrite this expression to be the integration of, now I'm going to get rid of the x squared plus 1, and I'm going to put u in place of x squared plus 1. So I get u squared. So the x squared plus 1 comes out, the u goes in its place, and that's where the u squared comes from. Then, over here in the second step, I have a replacement for x times dx. My replacement for x times dx is du over 2. Now that's the same thing as 1/2 du. So I'm going to take the 1/2, pull it out front, and I'm going to put the du in the back where it goes when we're writing an integration problem. So number 3 is to substitute. And when we substitute, we're substituting from here. So in this case, I'll put it down here. We would have our 1/2 u squared du. Step number 4 is to actually integrate. So I keep my 1/2, and I get u cubed over 3, which is u cubed over 6 when I multiplied, plus c. And then the last step, because I'm not really interested in finding this integration in terms of u, I need to go back to x's, so I'm going to re-substitute. Now my key to substitution is in my first 2 steps right here. That's how I know what to substitute. So I have, the u has to come out now. U is equal to x squared plus 1, so I'm going to put it back in. So I end up with x squared plus 1 quantity cubed over 6 plus c. And that's the substitution method, because notice I had to do a little bit of manipulation. The manipulation occurred because when I found the derivative of the inside function, I had the x, but I didn't have the 2. And so I had to do a little bit of manipulation to make that work so that the derivative was in there for me. All right, now I know at first this seems a little bit cumbersome, but let's look at a couple examples. The more you do this, the easier it becomes. All right, example number 1. Step 1, let u equal to the inside function. take the derivative of both sides. So I get the derivative of 1 is 0 minus 4x dx. I'm going to make my substitution. Now notice I have a 1 minus 2x, so that's good. I have a replacement for that. Now here I have a 3x, but down here I have a negative 4x. Well, I don't want the negative 4, so I'm going to divide it to the other side. I get du over negative 4 is equal to x dx. It's getting a little bit better, but I still have the 3 in there. So all I'm going to do with that 3, I'm going to do my rewrite here. I'm going to pull the 3 out front. I'm going to, except it looks like I wrote that kind of high. Let's bring that down. So there's my 3. I'm going to substitute u in place of 1 minus 2x squared, so I have u to the 1/2 power. The x multiplied by dx, here it is right here, x multiplied by dx gets replaced with du over negative 4, which is negative 1/4 du. I'm going to put my du in the back and my negative 1/4 in the front. I'm going to find the antiderivative, so I have negative 3/4 u to the 3/2 power multiplied by 2/3. The 3's divide out and the 2 divides into 4. That gives me negative u to the 3/2 power over 2 plus c. And then the last step is to resubstitute. In other words, take the u out. So u was equal to 1 minus 2x squared. So I have negative 1 minus 2x squared to the 3/2 power over 2 plus c. All right, let's see if we can get one more example in here. Example number 2. I'm going to rewrite this to be tangent of 5x quantity cubed times secant squared 5x. Now it's interesting that I wrote the first one as a quantity and the second one as not written as a quantity, but I'm thinking ahead. Remember, the derivative needs to be involved here. So my inside function in this case, u, is going to be the tangent of 5x. Take the derivative of both sides, so I get du equal to the derivative of tangent is secant squared of the angle times the derivative of the angle, and there's my dx. So I have a replacement for tangent of 5x. I can put u there. I have a replacement for secant squared 5x dx, but that 5 right here is in the way, so I'm going to divide it out to the other side. Get du over 5 is equal to secant squared 5x dx. So now my du over 5 can be put in place of secant squared 5x dx. So now the integration becomes, I'm going to pull my 1/5 out front. I'm going to put my du in the back. U goes in place of tangent 5x, so I get u cubed. So when I find the antiderivative, I get u to the 4th over 4. When I clean that up, I get u to the 4th over 20. And there's my plus c. This part doesn't really matter because I want the function in terms of x. So now I'm going to resubstitute. Remember, here's my substitution. Tangent 5x goes in place of u, so I get tangent 5x to the 4th power over 20 plus c. All right, so take a look at this as often as you need to and review it. The more you practice it, the easier it becomes.